Now let's start with the breadboard. The breadboard has many strips of metals which runs underneath the board. The metal strips are laid out as shown below. So this is our breadboard, and this is what you can see underneath the breadboard. These yellow lines indicates a metal strip. Okay, as you can see from here, there is a red line. There is a red line here. Okay, this red line indicates that there is a metal strip. There is a long metal strip which are from this point up to this point. It means to say, if you look at the front of the breadboard here, this red line here represents that this metal is from this point here up to this point. Okay, so that means this very long line is considered as one node or one terminal. What about the blue line? Blue line, sometimes you can see a black line here. The blue line is, look at this metal strip, also from this point up to that point. It means to say that from this point up to that point, it is one node. Now look at this portion. This is vertically oriented. Vertically oriented, it means to say that this is one node, another node, another node, and there is no node from here up to there. There is none, because there is no metal strip. So if I want to connect this node here together with this node, I just to put a jumper wire, and they will be considered one node from this point up to this point. So you need a jumper wire to connect, let's say, this metal strip to be connected with this one, then they will become one node. And this partition here, that means there is no connection. Okay, and here also is the same as this part. Okay, now let's just talk about the breadboard that we are using in the lab. Now in the lab, actually we have this breadboard. Similarly, you have a black line here at the top. Okay, this black line here represents a metal strip. That means from this point up to this point, this is one node. And there is a red line here that is from this point up to this point. That means there is a metal strip behind. So this is considered one node from this point up to this point. And here, there is no connection, but here is another node. So if I want to join this from here to here, I had to connect a wire from here. I had to put jumper wire from this point up to this point, then they will become one node. This portion here is similar to this portion. What about here? As you can see, is horizontally oriented. Horizontally oriented, so the node is horizontal. So there is no direct connection from this point up to this point. You can see from here, it's very clear. So here is the partition. There is no connection here, and also here partition. What about this point? Here is similar to the top side. This is similar. Okay, but there is red is on the top and black is on the bottom. But here, what can you say about this? This is vertically oriented here. So it's from here to here is one node. Okay, similar to this part. Okay. Now let's go to some basic connection. How to connect a series and parallel resistor. So let me just have a pen. So here I place a resistor here, as you can see, and there's another resistor here. If I want to connect it in series, I'll just put it from this point and I'll put it here. Now they are in series. Now if this is my positive terminal, and this is my negative terminal here connected to this, I can connect a wire from here going to the red, and from here going to what? Black. Okay, so now we have what? We can say this is a complete loop, right? This is a complete loop. Then this is the flow of current. Current will enter here, and it will return to the negative. So this connection is series. So now, how to connect resistors in parallel? How do you know that the components are parallel? If there are at least two nodes common to each other. So let us create two nodes common to each other by putting a wire from here up to here. Now one node is there, and here up to here. Now this resistor now in parallel. Now we can connect it into a positive voltage source if this is negative and this is positive here. Okay, it's not shown here, but let us imagine that there is a node here. Okay, that's, I will put the positive here on the top, and I can put here negative connected here. Okay, negative. So this will become the source current here and another current coming back. What about here? There are branch currents going to the resistor. What can you say about this current? This current is the summation of this current plus this current, right? Okay. Now let us try to define what is a node. A node here is a point in a circuit where two or more components are connected. Now the connection between different components are formed by putting their legs in a common node. Now look at this resistor and this resistor. The common node between them is this one, right? This is also a node. This is also a node. This is also a node, and this is also a node. So this circuit now has actually 5 nodes connected to here, positive and negative. So we have a complete loop also. Now, suppose you are given this circuit. Now you are asked to assemble it in a breadboard, okay, and analyze the circuit. So I had connected it here in the breadboard. As you can see, I connected it already. This is 330 ohm, which is here. Okay, 330, 1.2K, 270, 390, 390. Where are the nodes? So nodes are A, B, C, D, E. Where are they? This is A, this is B, this is C, this is D, this is E. And it connected now to a voltage source, which is here positive and negative, which is not shown here, but it is, let's just assume it's connected to the voltage source. Now, sometimes maybe you have seen an integrated circuit, a chip. Okay, this chip actually is in the breadboard, it is mounted like this. So if I'm going to zoom this, as you can see, these legs are connected on the left side, and these legs are connected in the right side, and this partition, that means left legs and right legs will not be shorted together, and you can connect it here. So this is how, just to show you how breadboard is being used in a project, so that at least you can have idea how to use it. Now, let us have a simple review. From these 3 resistors, which of the following resistor is wrongly connected? Is it number 1, number 2, or number 3? Let us examine number 1. It is connected here, that one leg is here and one leg is opposite. So it's correct. Correct this one. So number 2 is also correct. This is node. This is separate node. The resistor is being placed in 2 different nodes. And what about this? So number 3 is wrong because it's connected to this node and to this node, which are only similar nodes. So this resistor is shorted, right? Shorted. So like this. Okay. Now, so I will remove this this resistor. I can connect it to the power supply. This is the power supply. Connected here positive, connected here negative. Negative is black normally. Positive is red, and I can connect it here. Look at this. I put the wire here, and there will be a complete loop, then current will flow. Okay. What about this? This chip, which one is wrong? Okay, obviously, this number 2 is wrong because these nodes here are connected. So the IC is shorted. So this one here is wrong. Now, multimeters. Multimeters are commonly used to measure voltage, current, and resistance. These are the 3 commonly used of multimeter. But multimeter actually has different functions. If you can zoom here, we can measure voltage. If you want to measure voltage, you just put the knob here. Resistance and also current. This portion here are all for the current. Okay, it's similar with this model. This is voltage, AC and DC, resistance, and these are the current. So notice here, the red probe can be placed in voltage ohm, right? This symbol is voltage in ohm. This is always there when you are measuring voltage and resistance. What about current? If it is current, you have to put this red probe on the milliampere, and the black one is common. You should not change the location of the common probe of the multimeter. You need to change only the position of the red probe. It's either here or here. Okay? Now, let us go to how to measure the voltage. As you can see from here, I have a voltage source, positive on this side and negative on this side. That means this current will flow from this point, right? So that means this portion of the circuit is more positive than this, right? And this, with respect to this resistor, this portion is more positive than this. Okay, as we all know that the red probe is for positive. So if I put a red probe here, red, and I put a black probe here, okay, it means to say I'm going to observe a positive voltage. My reading will be a positive voltage. Okay, so if this is the current going there, then it will return to the negative. Okay, now if I reverse this, I will make this as black, and I will make this as red. Okay, so it means to say I'm going to observe a negative voltage. Okay, so if your voltage measurement is negative, it means that your polarity, you need to check the polarity of the probe. As you can see here, the red probe is on the voltage, and this one, it should be on the voltage, not in the ohm. Okay? Now, next is to measure the current. To measure the current that is passing through, take note of that word, any branch in the circuit, set the meter in either DC or AC. In this case, we are using DC. And the pros in the right place in the meter. Okay, this is the source. This is more positive than here, so the current is there. Okay? The current must enter the positive part of the component or the meter. If this is the resistor, this is more positive and this is negative. If this is the ammeter, this place must be more positive compared to this side. Right? What I did here is that there is a wire here. Open the wire and insert the ammeter. And this one here is more positive than this one. Therefore, if I connect a positive probe here and negative probe here, I'm going to expect a positive current reading, right? But if I interchange it, I put negative here, I put positive here, with this connection of the voltage source, I'm going to observe a negative current. And take note, this red probe must be placed in the milliampere or in the ampere. Okay, so I remove it from here and I put it there and I rotate the knob. Okay, now another use of multimeter is to measure the resistance. Now, to measure the resistance of a circuit, so suppose it is a circuit, you want to measure the resistance connected to the voltage source, you had to disconnect the power source. Suppose I have a source here, I had to disconnect it and I will try to measure now the resistance. This is for safety. And or otherwise, if you have one single resistance, this is your resistor, you have to put it in the breadboard, in the hole of the breadboard. Okay, hole of the breadboard, and with your ohmmeter measure directly from the resistance across these two terminals. This is your resistance. Okay, now you may also hold the resistor, but make sure you're holding only one side of the resistor, because if you touch both sides, our body resistance will interfere on the accuracy of your measurements. So it's wrong. So you can hold one side only and put let's say you put the red probe here and the black probe here. Then you can get the resistance of our resistor. Now, suppose I place it here. What can I get? What measurement I will get? I will get R3 parallel with R4, right? Okay, if I transfer the ohmmeter here, I will get R2 parallel with, in series with R3 parallel with R4. What about R1? there is no effect in R1 because this is open here, open, right? But if I move here, it will be R1 plus R2 plus R3 parallel with R4. Okay? Now, it should be put placed here and you have to put it on the ohmmeter. Now, resistor color codes, the nominal value of the resistor can be obtained, okay, from the color of the drawn on it. The first two bands form the mantissa of the resistance value, and the third is the exponent of 10. The gold means 5% tolerance. The silver means 10% tolerance. This is the port band. This is a port band resistor. This is 1, 2, 3, 4. This port band is the tolerance. So from this example, what can we observe from here? Okay, we can say this is red. Red means 2, right? So it's written here 2. Brown means 1. And orange means 3. So 2, 1 times 10 to the third power. That means 21,000. And the tolerance is silver. You can see from here. So plus or minus 10%. Okay? Okay, let us have an example. What is the resistance values of each resistor? So we have brown, black, orange. So 1, 0 times 10 to the third power, right? Plus or minus, it's gold 5%. Nominal value 10,000. And lower limit value is 9,500. Upper limit value 10,500. Why is it only 9,500? Because you had to subtract 5%. Why is it 10,500? You had to add 5%. This is the lower limit, upper limit. What about this? Brown, black, green. It will be 10 times 10 to the 5th power. Okay? So it will be 1 mega ohm. Okay? So 9,950,000 lower limit, 10.